Hey, I'm Richard, and this is my partner Austin, who's recording. And today we're going to teach you integration by partial fractions. So let's get down to it. So we have our first problem, the integral of 1 over x squared minus 6x plus 8. And you can't integrate this using any traditional methods. This is an advanced integration method that we're going to teach you. So from here, let's just simplify it down to x minus 4, x minus 2 on the bottom. So you got your basic form here. And what we're going to do is we're going to literally split this in half. So let's put another arrow here. We turn this into some number constant a, x minus 4, plus b, x minus 2 on the bottom. From here, we try to get a common denominator so that we can cancel the denominators out. So this stays the same, but here we're going to multiply a by x minus 2 and b by x minus 4, and the same thing with their denominators. So this becomes this. And all we did is multiply the numerator and the denominator by the same things so that they still cancel out. This is the same thing as before, but now we can actually cancel out the denominators. So cross these out. You're left with 1 equals a x minus 2 plus b x minus 4. Okay, so we have a small problem here, and that's that we have two unknown constants, a and b. So in order to isolate one of them, we're going to have to cancel out the other. So let's just plug in some x values, see what happens, hopefully isolate one of these. So let's say, obviously, this one's pretty obvious, x equals 2. That'll cancel out a, and let's put that over here. B 2 minus 4 equals 1. So 1 equals negative 2b. b is equal to negative 1/2. Alright, that's good. So let's say give x equals 4. That'll cancel b over here. So 1 equals a times 4 minus 2. 1 equals 2a. A equals 1/2. So now we have our a value and our b value. And if we go back to the beginning, what we did before, we can actually plug these values in for a and b. So let's go all the way over to the top here. The integral of 1 over x minus 4 minus 2 is equal to 1/2 x minus 4 plus negative 1/2 x minus 2. Now we can actually take the 1/2 and the negative 1/2 outside of the integral. So what we get is 1/2 the integral of 1 over x minus 4 minus, really you're doing plus negative 1/2 the integral of that, but we can write that as minus 1/2 the integral of 1 over x minus 2. Okay, so from here, if you remember any of your integral equations, you can actually make this, you can turn this into 1/2 the natural log of x minus 4, absolute value on both sides, minus 1/2, same thing over here, the natural log of x minus 2. Don't forget a plus c, since this is an indefinite integral. We can factor out a 1/2, simplify it even further. And finally, if you remember any of your logarithm properties, you know that you can actually turn this into the natural log of x minus 4 over x minus 2. And then with this plus c. And this is your final answer to that. So that's how you do integration by partial fractions. And that's example 1. And Austin will be there to do another example.
Hi, this is Austin, and you're back with Richard and I, and we're going to do some more partial fractions, but here's number 2, so let's get started. So you got integral right here. Okay, we're here with this integral of 1 over x squared plus 5x plus 6. First thing we want to do is get it factored out on the bottom. So we can see right now it's a pretty simple factoring. This is 1 over x plus 3, x plus 2. And we want to take these two right here and put it over a over x plus 3 plus b over x plus 2. We still have that all equal to 1 over x squared plus 5x plus 6. Now since we have that, we want to get some common denominators over here. So we're going to multiply a by x plus 2 on the numerator and the denominator, and then b by x plus 3 over on the top and x plus 3 on the bottom. And then we're going to do the same over here. So let's go ahead and do that. Oops, this is supposed to be x plus 3, sorry. And then right here, since this is x plus 3 and x plus 2 on the bottom, when we multiply these out, it's just going to cancel out the denominator over here, so I'm not going to write that all out again, so we're just going to set equal to 1. And then we're going to have b times x plus 3 and a plus x plus 2. And then from here, so x equal to -2, or x equal to -3. Because when we plug in -2, we get a 0 right here, and we want to separate the variables to get an answer for b and a. So we get set x equal to -2 right here. We're going to get 0 times a, and just 1 after we subtract 3 from 3 and 2. We're going to get 1 over here. So 1. So we're going to have b is equal to 1. So let's set this over here. And then we're going to go ahead and put x equals -3, which is problem, which is going to cancel out b over here, since that would be b times 0. So we have -1 over here from -3 plus 2. Divided by -1. 1 divided by -1 is -1. So you have b equals 1 and a equals -1 over here. And we're going to refer back to where we got a over x plus 3 and b over x plus 2. And we're just going to plug those in. So -1 over x plus 3 plus 1 over x plus 2. Put those back in the integral. If we remember, our integral rules, we can take this negative on the outside right there, and then if you do u substitution, you're going to find out it's just a natural log integral. So it's just going to be negative natural log x plus 3 plus natural log of x plus 2. Don't forget your plus c, because it's an improper integral. And if we arrange this, so we could get ln x plus 2, subtract ln x plus 3. So we're going to use our natural log rules. So natural log x plus 2 divided by x plus 3 plus c. And there we have our final answer to the integral of 1 over x squared plus 5x plus 6 through partial fractions. I'm Austin, and thanks for watching. Guys, one thing to remember on number 2, I forgot to mention, is that you need to, when you do the integral, after you integrate and use the natural log rule, you need to make sure there's absolute values, not parentheses, sorry, just absolute values. All right.
And now the end is near, and so I face the final equation. My friend, I'll say it clear, I'll state my limits, of which I'm certain. I've integrated a million ways. I've integrated by partial fractions, and more, much more than this. I did it the right way. Questions, I've had a lot, but then again, Mr. Parr answered them all. I used the first and second fundamental theorems of calculus. I used each method, each specific step that we learned, and more, much more than this. I did it on the exam. Yes, there were equations, I'm sure you knew. UV minus VDU. But through the year, when there was homework, we did most of it with Wolfram Alpha. We derived it all and found it all and checked the end points. I've divided, I've added and subtracted. I've had my derivatives, my share of integrals, and now as volume increases, I find ERDT so easy to think. Calculus was hard, and may I say, what an understatement. No, not polar. We did it parametrically. For what is calculus? What has it got? If not limits, then it has not. To make the functions it truly deserves, and not implicit ones algorithm shows calculus truly grows, and we did it our way. Yes, it was Mr.